There's something in space that's so big it shouldn't exist. According to our understanding of physics, structures this massive aren't supposed to be possible. The universe shouldn't allow them to form. But it's there, and it's called the Hercules-Corona Borealis Great Wall. It's 10 billion light-years across. To give you perspective, the entire observable universe is only 93 billion light-years wide. This one structure takes up more than 10% of the entire known universe. Let me show you just how absurdly big that really is. Understanding light years. First, we need to understand what a light year actually is. Light travels at 186,000 miles per second. That's fast enough to circle the Earth 7.5 times in 1 second. A light year is the distance light travels in 1 full year. That's about 6 trillion miles. Now, let's build up to how big this structure really is, using comparisons. The Moon. Light from the Moon takes 1.3 seconds to reach Earth. The Moon is close. The Sun. Light takes 8 minutes to reach us. If the Sun exploded right now, you wouldn't know for 8 minutes. Neptune, the farthest planet. Light takes 4 hours to get there. Nearest star, Proxima Centauri, 4.2 light-years away. That's 25 trillion miles. Across the Milky Way galaxy, 100,000 light-years. Our galaxy is huge. But the Hercules-Corona Borealis Great Wall? 10 billion light-years across.
Scale comparisons. Let's make this simpler with a model. Imagine Earth is the size of a grain of sand. On this scale, the Moon would be a smaller grain of sand about 2 inches away. The Sun would be a ping-pong ball 26 feet away. The Milky Way galaxy would stretch 3,000 miles across, roughly from New York to Los Angeles. The Hercules-Corona Borealis Great Wall would be 300 million miles across on this scale. Even when we shrink Earth down to a grain of sand, this structure is still impossibly, incomprehensibly massive. Here's another way to think about it. If you could travel at the speed of light, the fastest possible speed in the universe, it would take you 1.3 seconds to reach the Moon, 8 minutes to reach the Sun, 4 years to reach the nearest star, 100,000 years to cross the Milky Way, 10 billion years to cross the Hercules-Corona Borealis Great Wall. That's almost as old as the universe itself, which is 13.8 billion years old. What is it actually? So what is this thing? It's not a solid object. It's not a wall you could touch. It's a massive cluster of galaxies. Thousands and thousands of galaxies all grouped together in a giant cosmic web-like structure. Think of it like a string of cities along a highway. The cities are the galaxies, and they're all connected by invisible threads of dark matter and gravity. From far away, they formed this enormous wall-like pattern stretching across the universe. Here's what it's made of. Thousands of individual galaxies. Each galaxy contains billions of stars. Each star might have planets, all held together by gravity. To detect it, scientists didn't actually see it like you'd see a wall. They noticed an unusual pattern. There were way more gamma-ray bursts, massive explosions from dying stars, coming from one specific region of space. When they mapped it out, they realized all these galaxies were connected in one gigantic structure. It was discovered in 2013, and scientists are still trying to figure out how it exists. Why it shouldn't exist. Here's where it gets really weird. There's something called the cosmological principle. It's a rule in physics that says the universe should be roughly the same everywhere. Matter should be evenly spread out. Sure, you'll have galaxies clustered together here and there, but nothing this big. According to the math, the maximum size a structure should be able to grow is about 1.2 billion light-years across. The Hercules-Corona Borealis Great Wall is 10 billion light-years across. That's like the universe has a speed limit of 65 miles per hour, but this structure is going 542 miles per hour. It's breaking the rules. So how did it form? Scientists have a few theories. Theory 1. The early universe wasn't as smooth as we thought. Maybe there were bigger clumps of matter right after the Big Bang, and gravity just kept pulling them together for billions of years. Theory 2, our understanding of gravity or dark matter is incomplete. Maybe there's something we don't know yet that allows structures this big to form. Theory 3, it's a statistical fluke. Maybe we just happen to be looking at a super rare cosmic coincidence. The honest answer is, we don't really know. Other massive structures. The Hercules-Corona Borealis Great Wall isn't alone. There are other massive structures out there. The Sloan Great Wall, 1.4 billion light-years long. This was the biggest known structure before 2013. The giant GRB ring, 5.6 billion light-years across, a ring-shaped arrangement of galaxies. The huge LQG, 4 billion light-years across, a collection of 73 quasars all grouped together. But the Hercules-Corona Borealis Great Wall is the champion. Nothing comes close. And here's the really mind-bending part. We can only see the observable universe. There's more universe beyond what we can see. That means there could be even bigger structures out there that we'll never be able to detect because their light hasn't reached us yet, and never will because the universe is expanding too fast. Let's zoom back out for a second. You are on Earth. Earth is in the solar system. The solar system is in the Milky Way galaxy. The Milky Way is in a group of galaxies called the Local Group. The Local Group is in the Virgo supercluster. And somewhere out there, 10 billion light-years away, is the Hercules-Corona Borealis Great Wall, a structure so massive it challenges everything we think we know about how the universe works. It's a reminder that even though we've learned so much about space, we still barely understand it. The universe is bigger, stranger, and more mysterious than we can imagine. And the largest structure we've ever found? It probably shouldn't even exist, but it does. This is Facts of the Universe. See you in the next video. Peace.